Okay, I'm gonna try to do another one for trigonometry. The problem for trigonometry is I don't know how to break this up because there's obviously stuff that everything that's done in ordinary has to be done in honors. But there's also different, like completely different topics or sections in trigonometry that the honors will have to do. So I don't know how I'm going to break this up yet. I might do one really long video, or might do one video that everyone has to watch, and then a separate video that just honors have to watch. I'm not too sure yet, but I'm sure I'll have that figured out by the time you're seeing this. But just know I'm conscious that, like, if I do one long video, it's going to be quite long, I imagine, because there's so many different parts of trigonometry to do in honors. But yeah, this is for both honors and ordinary, and it's just, this will show up in both paper 2 exams, whether you're doing honors or ordinary. And it's like I don't want to say the basics of it because I don't want to sounds demeaning to it, but like it's where it's simply just triangles, and you have to figure out about the triangles rather than dealing with sine and cos graphs, which is what the honors will deal with it separately. Sine cos graphs, you have to deal with the proof, the trigonometric proofs, the cast system or stack system or whatever you call it, the ASTC. And then there's these other ones where you have to like just play around with stuff where they give you sine or cos or tan, but they don't ask you for the actual angle, they ask you for a different variation of it. But we'll see about that. For now, we'll go through this, I suppose. You can get 2 different types of triangles, ones that have right angles in them and ones that do not. If they don't point out that it's right angled, do not assume it's right angled, because if you assume a non-right angled triangle is right angled, you get 0 automatically in some of the marking schemes. They're just like trying to do away with it. So, and it's if let's say it is a right, you might think, well, what if it is a right angle and I don't assume it's a right angle, and then I'll do the other wrong ones in that direction. But doing the harder ones, doing the ones for a non-right angle triangle on a right angle triangle, like doing the ones that would only work for this one on here actually work here as well, whereas the reverse isn't true. It's not that the formulas that work for this do not work for this one, you know what I mean? So the formulas from here do go this way, but the formulas from here don't apply to that one. So it's almost safer to just assume it's not right angled. But again, if they do like this symbol, or sometimes they'll do that in the corner of it, or they might just say it's 90, or they might put in, sometimes what they'll do in the question is they will say vertical and horizontal. That kind of implies that it's 90 degrees, because there's a vertical line, there's a horizontal line, and you notice it'd be 90 degrees. They kind of assume that. But yeah, we'll get into that, I guess, as well. Anything else I want to just say before we start? Yeah, remember that the 3 angles in a triangle have to add up to 180. Half a circle like this has to be 180. So if you have like 2 things like that, and you know one of them, you just do 180 minus that angle to find the other one. Those little bits and pieces are handy, because sometimes I think people get too tied up with trying to find the exact answer rather than, you know what I mean? They might say find this angle, but then everyone spends so much time finding that angle. If you could easily just find the other angles before even looking at that one, and they would drastically help you figure out in the end what's going on. Alright, then I guess I'll just we'll jump into it. The things that you have to remember is that for a right angle triangle, the side across from a right angle is always the hypotenuse, always. Now, the opposite and the adjacent are the other 2 sides, and in some situations it doesn't matter which one you pick. And for that, what I mean is, if you're asked to do Pythagoras' theorem, and now some of us, we have disagreements on this is the way I would have done it, but a lot of yous prefer it like this. And even some of yous will even argue that the C should be on the other side, but it makes literally no difference which way around the equals is. Like, it does not matter. But I would think this is the best one, because it already has the letters in it, the H, O, and A for the hypotenuse, opposite, and adjacent that we talk about. So I think that's kind of the handiest one, but you all disagree with me on that. That's okay. But this one doesn't matter which one is the O, like, or which one is the A, because regardless of whether this is the O or the A, or whether this is the O or the A, you're still just going to be adding two numbers together, and when you add two numbers together, it doesn't matter what order it's in. So if you only have to do Pythagoras, it honestly does not matter. But if an angle is mentioned, and this is something you'll see, so like when normally we don't know a letter or don't know a number, we'll put in the letter X for it. But for an angle, if an angle is not known, they use the letter theta. It's just one of the Greek letters. I wouldn't worry too much about it. It looks like an O, like a loop back around on the top with a belt going through it, something like that. It doesn't really matter. I know Miss Doonan in her thought writes something like that, and a few other people do it, so just watch out for that. But if that's the angle that they're talking about, then this would be the opposite because it's opposite the angle, and this would be adjacent because it's adjacent to the angle. Adjacent is just a fancy word meaning next to. If, for example, and I'll do it in blue because I don't want it to be like what people think we're doing. If they ask you to do that angle, and that's an alpha, I'll probably mention him a few times. He's just like a second version of theta. If theta is used, you can just use alpha or beta or gamma or whatever. But if that was the angle they'd chosen instead, you notice this would have been the opposite and this would have been the adjacent, and the maths would be slightly different. So just watch out for that. Depends on what angle they pick, is O and A. But again, for Pythagoras, it doesn't really matter. It only really matters for SOHCAHTOA. And this is going to be controversial to a lot of people because they all have their own ways of doing it. A lot of you promise me that you'll just know the letters. No, don't worry about it, Graham. I got this. I can just remember the letters. I'm class. And then you all get it wrong. And I have to try to deal with that. But just know, some people would treat it like that. That's fine too. But just know everything to the left of the red line would be sine, cos, tan. And then the right of the line tells you what the angle would be. So the first line, for example, would be sine. Now, some people pronounce it sin. I'm going to pronounce it sine. It doesn't make a damn bit of difference. You do what you want to do. But the sine, cos, or tan, whichever one you pick, the angle always has to come directly after it. Then it equals, and then the second letter over the third letter, if you get me. Like second in the list over the third in the list. Hopefully that makes sense. So, then the same would be for cos. But it'd be A over H, and then tan would be O over H. Or O over A, sorry, my apologies. For remembering this, different people have different things. As I said, a lot of people just remember, I just know SOHCAHTOA, but they're all vowel noises and H's, so I don't know if you're actually going to know it. People have oh hell, another hour of algebra. Oh hooray, another hour of algebra. Olive has a heap of apples. Some people include all the letters and do silly old Harry Cotta herring trawling off America. We had silly O'Hare's class always have their own answers. You can come up with your own ones. What I will say about SOHCAHTOA is you don't need to remember it for the entirety of the exam. You just need to remember it for the first minute, right? So the day before your exam, the 5 minutes before your exam, have that written down somewhere. Remember the three lines, the 9 letters. And in the exam, the minute they tell you can start, just without reading the questions, just slap that down. Because then it's on your exam and you won't have to remember it for the rest of the exam. Whenever you need it, whenever you see you have to deal with SOHCAHTOA, whenever you have a right angle triangle, you can just revert back to where you wrote that in the first page. Okay? I just think that's kind of handy because it's in your log tables, but it's slightly different. I should point out that all of these formulas I'm going to go through here are on page 16 of your log tables. Just maybe in slightly different formats for the right angled ones, which are on the bottom for some reason, but yeah. So is there anything else I wanted to say about the right angle triangle? I'll go through an example of one of these in a few minutes, but I just kind of want to get all the basics out. Sorry, someone is messaging me. Yeah, so, just as I said, just remember sine, cos, tan. Pythagoras' theorem, you all seem to like it, so that's okay. That's not too bad. Sine, cos, tan. Sorry, the texts have kind of thrown me. I thought it was something else I wanted to say, and I just can't remember. But I'll move on. If I remember it, I'll come back to it. Yeah, okay, well, we'll start with the next one. The important thing that you have to remember for the next one is there's no right angle, and so therefore there was no hypotenuse. There was no way of us coming up with a lettering system for it like that. So instead what we did was we went, I don't know how people feel about this, but they give you in the log tables anyway. I'll do it like as if it's in the log tables. What they will do is they will say you call the three corners A, B and C, and then each angle is the capital version of the letter, and then the side across from that angle is the small version of that letter. So this would be capital A, and this would be small a, and this would be capital C, and this would be small c over here. Now, my problem with that is that that's how it is in the log tables, but they kind of know that in the exams. So what they do is, and I think they do it on purpose, they kind of pick three random ass letters just to throw you off. So what I like to do is I like to pick three random ass letters and just kind of show you how the formulas would work with my letters, because there will be no pattern to my letters, and then you'll know that the formulas don't follow the pattern of the letters, they just follow their own format, and you can put in whatever letters you want into that format. So just to play it simple, I think one of the times I just picked my initials. So we'd have capital G would be there, small g would be there, capital A would be there, small a would be here. No, it wouldn't, Jesus. Small a would be here, capital M would be here, small m would be here. Alright, because I didn't mess that up. But that's how we would denote the things there. That the corners, the angles, are the capital version, and the sides are the small versions. Yeah, now you can't use these formulas here for something that doesn't have a right angle, so we can't revert to any of those. So we have to use the formulas they're in the log tables as well. There's the sine rule, which states, and I think in the sine rule it's written like this, where you can make a fraction out of the side divided by the sine of the angle that matches, if you get me with it, and they're all equal to each other. Now, as I was saying, in the log tables I think it's this way around. However, in the exam they might ask you for a certain thing in which it's actually easier to do this, where you flip them all. Now it might be that in the log tables it's the blue version or the red version. I think it's the blue one, but whichever one it is, you can always just invert them all, flip them all upside down, and just get and like effectively it's the same formula, but it just makes things easier for the algebra. If they ask you for one of the sides, as in one of the small letters, it's easier to use the blue one at the top, because then all the letters that you're looking for are automatically placed on the top of the fractions, whereas if they're asking you for an angle, it's easier to use the red one, because again then the one you're looking for is automatically on top even before you start. So that's the sine rule, or sin rule, again whatever you want to pronounce it as, that's fine. And then the cosine rule, now again, because I picked different letters, I can't really show it. Well, it kind of looks like this, right, where it starts off looking like Pythagoras' theorem, because Pythagoras' theorem is derived from this, but you don't need to worry about that. Now, you'll notice this is very similar to log tables, but again, they use A, B, and C. The only important thing about this format is, obviously it has to be this shape, but whatever letter is here matches with whatever letter is here. The capital and small version have to be on the outside, and then the other two small letters go inside. So again, in red I'll do like kind of alternate versions that could show up, but these are all fine. It doesn't really matter, because sometimes what they'll do is they deliberately give you questions that have like A, B, and D in it, in the hopes that you'll kind of panic and you'll think, I don't have an A, B, and D in my log tables. I have A, B, and C. And then you don't. Sorry, that square shouldn't be there. Jesus, that's a point I want to make. That square should not have been there. I wrote in a square there automatically, and I've just noticed that. I don't know why I was doing that. It's not supposed to be there. But yeah, my whole point that I'm trying to do is I'm trying to show you that the outside letters have to match. If you follow me, the first letter and the last letter have to match. The small letter that's on its own, and the big version of it that's at the end have to match. Sorry, I'm all conscious about messing it up now because I was putting the squared in the wrong spot there. So all of these would be suitable cost rules. All of them are fine. Again, in the log tables they give you one version of it for A, B, and C. I think they do A at the start and A at the end, and then B and C in the middle. But it does not matter. They all are fine as long as you follow like the format, if you get me, the layout, the template of the thing in the formula in the log tables. So the sine rule says that the side and the angle have to go together in a fraction where it's sine of the angle, and then they'll all be equal. Cost rule says fill in this format, but the last and the first have to match. Now we'll talk about this more when we're doing the questions as well, but well, no, I'll tell you what, I'll get the area one out of the way, because the area one is kind of like, it's common to both almost, but there's a way around it for the right angle. But in general, the area formula is a half, they'll say half AB sine capital C, and again we can use any letters. That could be a half, for me it would be like a half AG sine M. And the important thing is that whatever capital you're using, the small version can't appear here. It's whatever capital you use, the other two letters appear as the small versions. So I could also have done mg sine A, and that would have been the same answer as this one. It just means you get to use different information, so it kind of depends on what information you have. Whichever angle you want to use, you can't use the side opposite that angle. Yeah, I think that's handy enough just to get that out of the way. That's just the area formula. I think you all kind of know how area works. Just kind of, fill in the information that you have, that you can fill in. So for the right angle triangle, how you can tell which one you're going to use is the Pythagoras' theorem one is very, 99% of the time used if you have two sides and you're looking for a third. The SOHCAHTOA is used if in the right angle they mention an angle, basically, right? Obviously there's edge cases, and they've noticed patterns recently that they're trying to do away with, so they're starting to make things a bit more spicy. They're starting to throw in just a few bits and pieces here and there that you want to watch out for. But the only, for example, for the right angle triangle, I'm saying that it's 99% of the time you do it if they have two sides and if you give you two sides and they're asking for a third. But they can also technically, let's say that's a right angle triangle where this is, you don't know either of these, but they're both x, they're both the same thing, and this is 8. Does 8 work? Because you'd have to, 8 works, I think. Because if you then did Pythagoras' theorem for this, keeping in mind that the hypotenuse is always the one that's on its own, so for me that would be the 8 is always on its own, so that would be 8 squared. So 8 didn't work, I don't think, the way I wanted it to, but either way, it would be 8 squared is equal to x squared plus x squared, because again, it doesn't really matter which one is the only a, particularly here, because they're the same. We'd end up with 64 is equal to 2x squared. And the reason why it works is because you'll notice when you fill it in, there's still only, even though there's technically two parts we don't know, there's one unknown in the maths. There's only one single x term. Divide both sides by 2, and it just becomes algebra. A lot of this trigonometry stuff will be setting it up, will be the trigonometry part, and then a bit of algebra thrown afterwards. And then the square root of 32 is 4 root 2 maybe, I don't know. You guys have fancier calculators. You don't need to know how to do that. Your calculator will tell you how to do that. You just know that to get rid of the squared on one side, you square root the other. But that's the one edge case I can think of for Pythagoras where you don't need to have two sides. There I only had one, but we were able to figure out the other two because there was only one unknown variable in the question. I'll find some questions now and do them out. I'm just trying to think. Yeah, okay, and then so that's how you figure out how to use which one for the right angle triangle. But for the non-right angle triangle, the way you tell is, and again there's an edge case someone has brought up to me where this doesn't really work. We use the sine rule if you have a matching pair, basically. So basically if you have the capital G and the small g, or the capital M and the small m, or the capital A and the small a, then you would use the sine rule. And then obviously if not, the cosine rule. Not that. But that's kind of how you tell. Again, there was an edge case where someone brought it up, but I will try to pause this, I guess, and try find some questions to do. I'm gonna have to go as well to do actual do maths with some people in a minute, or in a few minutes. So I'm gonna have to. There might be a big gap then that might be noticeable when I'm coming back to this. Okay, so I know I said at the end of the last bit that I was gonna just pop away, come do some maths, and maybe come back to it, but it's like a week has passed since. It's constantly just things coming up, and I just never seem to get ahead of it. I was always just like reacting to things rather than actually getting ahead of it. So hopefully I'm able to kind of just continue on from where I was, but we'll see how it is. Obviously all the maths will be the same. It's just kind of remembering what I did and didn't say. In the large part, everything's going to get covered, but it's just the little bits every now and again that I might be like, oh, when I'm thinking of making this, I'll be like, oh, remember to mention this, this, and this came up in one of the years. Hopefully that type of stuff, I remember all that stuff, but we'll see. Yeah, so the last day I just went through all the formulas. I went through one edge case of how you might need to use the Pythagoras' theorem, even though, because normally I would be saying use the Pythagoras' theorem only if you have two sides and looking for the third, and then I said that's like 99% of the time. The odd time it's like this. And then the rest of the formulas, again, these are all honours and ordinary leaving cert. Everyone needs these in leaving cert. Yeah, okay. I'm just having a look at what I have just to kind of catch up. I did watch all the stuff that I'd done already up until this point, and it was I don't know. I just like, no one likes listening to their own voice. Obviously, it wasn't the most fun. But hopefully I have everything mentioned in there that I wanted to mention that I didn't remember something that I'd forgotten about since then. Anyway, what I did was I went to the exams and I just got a couple of examples. It's not going to be exhaustive. It's not going to cover every scenario that could possibly come up. Particularly in the past few years, they've started getting a bit weird with it, where they're trying to change it up so that you're not just doing the same question year in, year out. So that I think the logic is they want to see that you understand the maths rather than you've just learned what to do. You've learned what the pattern was from the past 3 years or so. But we'll see. After COVID, we still have to see how it kind of like calms down again. Maybe they stay weird. Maybe they go back to normal. Now, two of these examples were from an ordinary level paper. It's still just going to cover the right angle stuff. So it's still stuff that could come up on the honors. But basically. And they won't always do this. You'll notice here, actually, they did this quite nicely where they said use the theorem of Pythagoras, use Pythagoras' theorem. So straight up you have to do that. But they were saying here, use the theorem of Pythagoras to find the length of the distance marked D on the diagram below. Give your answer in meters, correct to 1 meter. So 1 decimal place. So what basically they're saying is, they didn't really mention this, but what we have to assume is, we're going to have to look at this because it is a right angle triangle, which would allow the theorem of Pythagoras to be used, and there's no other real right angle triangle that you could really use there that would contain D and allow us to use Pythagoras as it's a right angle. Again, I don't know if I mentioned this. Now, this is something I don't think I mentioned this in the earlier part, but when you're doing trigonometry or anything, I suppose, really, don't scuff up the diagram they give you. A lot of people will like put like bits and pieces in here and it just makes a mess of it, and then you get to like question B or C and you need to look at it and you're like, oh crap, all of it's either covered, or it could be that to do this question we're going to label this as H, let's say, for the hypotenuse, but then when you look at it as part B you don't need it to be the hypotenuse, and that's just in the way, and you might be okay with it, but it just can kind of clutter your mind sometimes. So you'd have to recognize this is the right angle, that the triangle that they were talking about. They didn't mention it, but it was kind of a hint that they said use the theorem of Pythagoras. That means a right angle triangle that has to contain D in it. And you'd have to, even before using trigonometry, you'd have to use some sort of thinking right here. And I know I've just thrown this at you, but if you see the full height of the shed or whatever it is 8.5 meters, and this bit is 7 meters, then this little bit here must be what the difference between 8.5 and 7 is. So that's going to be 1.5. And then this bit here, you'll notice, is half of this guy, so just 6. And then you notice this guy is D, but I'm going to, instead of calling it D, I'll call it H. And I'm okay messing up this diagram because this is my own one. If I mess this up, I can literally just put a line through it and start it again, and I can still refer to the original thing, so it's fine. Pythagoras' theorem, and we know we're going to use Pythagoras. I know it said it, but even if it didn't say it, we'd know to do it in an example similar to this because neither of these two angles are mentioned. If one of those two angles is mentioned, like in this question, it's like a big kind of hint that you're going to use SOHCAHTOA. Again, all of this is assuming it's a right angle triangle. It's either SOHCAHTOA or Pythagoras are using a right angle triangle. I'm just assuming you guys are up to date, whereas I'm a week out, But yeah, again, Pythagoras' theorem, as I think I warned you in the previous thing that it can be written like this is the way I would write it. You guys would write it like this, a lot of yous. Both are fine, as long as you recognize the hypotenuse is the side opposite the right angle. I shouldn't say opposite. The hypotenuse is the side across from the right angle. And it's the one that has to go on its own. So in both of these scenarios, the underlined ones would be where you'd sub in the D, because D is the hypotenuse. D squared. These two matter in. It matters which one is the opposite, which is the adjacent in SOHCAHTOA things, but not in Pythagoras, because you notice no matter which way around you put it, you're just going to square two numbers and add them together anyway on the calculator, I would hope. So it doesn't really matter what order they're in, you know what I mean? Both of these things would be the same. So for Pythagoras, it does not matter. A lot of people I see struggle with kind of saying, well, I know where H is obviously in this question, but which one is O and which one is A? We don't really need to know which one is specifically which unless we have an angle involved. So here I'm just going to use the top one, but the one I rubbed out would have been fine as well. And that is going to be, that's 36. What's that? I think that's 2.25. Don't judge me if that's wrong. I think that's right though, but don't judge me if it's wrong. And then you get 38.25. And this is kind of algebra at this point. Again, this is the trigonometry part, and once you set up the trigonometry, and the trigonometry questions in ordinary level anyway, they give you a lot of the marks just for those two lines. But always don't forget, algebra wise, if you have D squared equals some number, to get D, the opposite of squared is square root. Don't forget that. And the square to that is, I don't know. Rounding is also something apparently you guys are all shite at. I don't really know why. I think it's just a lack of practice from COVID times, but I do feel, I'm afraid that sometimes if I keep saying that, you guys will just be able to take it as an excuse for not doing anything. And you notice they said round to 1 decimal place, correct to 1 decimal place, and that would be 6.2. Just a quick note on that. They want 1 decimal place, so they want these numbers. So you look at the next number, and is it 5 or above? Yes, therefore you increase this number here by 1. Otherwise you leave it as 6.1. If the number, instead of an 8 there, it would have been a 2 or a 3 or a 4 or a 1 or a 0. We would have just left it as 6.1. But yeah, that's Pythagoras. Handy out. Again, you tell you're gonna use it if you have 2 to 3 sides, if they don't mention an angle, all these things. But I'm gonna jump to this one over here now. I'm sorry I'm not doing it from left to right. But top of some tower or lighthouse, sorry, is 49 meters above sea level. The angle of elevation. A point I want to make: angle of elevation is the angle that you would have to go up at to elevate yourself. Everyone said, it's something that people do where they say elevation and go, elevation means like elevated is high, so this must be the angle of elevation, which it is not. This is the angle of elevation here, all right, and I might have scuffed that a bit, but the angle of elevation is the angle you have to go up at to get to a height. This angle here, this one, if they'd given you this one, would be the angle of depression. And every single time I say that to you, you all say, lol, me, or oh, that's my, these are all gas, hilarious people, right? But angle of elevation is the angle at the bottom, angle of depression is the angle at the top. It's not where they are, it's like where those angles would bring you. The angle at the top is bringing you down, the angle at the bottom is bringing you up, if you get me. 1.2 degrees as shown in the diagram below. Now ordinary people only do degrees. Ordinary and honors obviously it can be in degrees or radians, so you just have to watch out for that. Make sure your calculator is set in the right one before you start. For any of these questions, make sure all the units are the same before you start, because sometimes what they might do is, let's say this is 49 meters and let's say this is 3 kilometers. Before you do the maths, these two have to match. So what you do is you'd say, well, 3 kilometers is 3,000 meters, and then use that instead. The units have to match each time, right? Now, obviously, you didn't do it here, and I'm sorry for getting sidetracked, but when I'm doing these questions, I can just kind of remember the edge cases that I'm just throwing your way, just in case. But yeah, it's a right angle triangle again. They mentioned an angle, so it's like hint, hint. We're going to be using SOHCAHTOA, and you'll notice even there you wouldn't have been able to use Pythagoras here anyway, because we'd have been able to fit in one of them, but not this guy or this guy. So we'd have 2 out of the 3 things left just as unknown letters, and you can't actually mathematically solve that on its own. It's also not the scale, because that is definitely not 1.2 degrees. That's fine. All of this crap you can kind of ignore, though. When you look at that, all of that crap is in the diagram. You want to make sure, no matter what the question is, even outside of trigonometry, you want to make sure all the information they give you in the question and the diagram match, because sometimes they'll be sneaky snakes and they'll put one in the other. Like they might put information in the paragraph at the start that they don't put in the diagram, or vice versa. And you just kind of want to keep an eye out. But if it all matches, you just don't need those words, because I know those words kind of throw people off a lot. Find the horizontal distance, mark D below, from the ship over here, I guess, to the base of the lighthouse. Give your answer in kilometers. Okay, well then, you know. Okay, we can do that. We'll just get the answers in meters and then turn it into kilometers. Now, what you do is you'd label it HO&A. We all know that's the H because it's across from the right angle. Now here, obviously in Pythagoras it didn't matter for the opposite and the adjacent. Here it will. Here's the angle they mentioned, so therefore the one opposite that will be the opposite, and the one adjacent to it will be the adjacent, or the third word, as a lot of you remember it. Now, this is like the hard bit people have. I'll write SOHCAHTOA here just so we have it as an example. But this is the part people do not kind of grasp. And I think with the current year in particular, third year trigonometry was interrupted by COVID for you guys, so all of this is a bit scuffed, and I'm going to have to talk about similar triangles as well for the honours, even though it's not in my mind. Well, I don't know, we'll see. But you notice we had the opposite, and they're asking us for the adjacent. They neither gave us the hypotenuse nor asked for it, therefore we do not care for it. It won't help us find another thing, and even if we find it, who cares? Who actually cares? So what we're going to do is immediately we don't care about the ones with the H. We want this guy, because you'll notice it connects the O and the A. And now I think I hinted about how to set these up earlier, so I won't really go through it. But basically you will always pick the sine, cos, or tan, whichever one you're picking. I'm picking the tan, obviously, because it's T. And you put the angle next to it. If you don't know the angle, obviously, you put theta instead in this place, but, you know, because we knew it, it's fine. And then you put it equal to the second letter, which is O, over the third letter, which is A. And you fill in anything that you have. 49 over D. So really, this is tan of 1.2 equals 49 over D. And in ordinary, if you get to that stage, it's a lot of the marks actually just simply because you've set up the question correct. You've done the trigonometry part most of it correct so far. The rest looks like a lot because there's a bit of writing, because each line you have to do, you know, separately. But it's all just algebra, and as a result, there's not a lot of marks going for it. So obviously, you know, don't just not do it. But now there's a couple of ways of doing this with the algebra, and I'm going to do it probably the way I like doing it, but I know that might cause some issues. Basically, if you have something under a fraction like this and you want to get rid of it, multiply on both sides by that thing. Some of you treat it as you move it up here and it becomes multiply on the other side. That's okay, whatever. But you multiply on both sides because then it will cancel out, because it's dividing and multiplying by D are the opposites of each other, and they're gone. So then our next line would just be D multiplied by tan of 1.2. But then what's the opposite of multiplication? It's division. So we'd have to divide both sides by tan of 1.2. A lot of people would have jumped automatically to the inverse, but I'll talk about that in a second. That's a specific case, but I'll talk about that. That's a 1.2, right? Don't judge me. But if you multiply on both sides by that, or divide on both sides by that, it cancels out, and you're left with d equals, which is what we're looking for. They asked us to find what the d was, and we have it equal to, now it's equal to something horrific, but on the calculator, that's just stuff you can just type in straight away. So I'm going to just do it now. Give me a split second. I'm in radians, of course I am, so give me another second. Okay, hopefully I've done this right now. It will be 2, 3, 3. That is one of my biggest fears, that I'm going to do something wrong. Not because it's going to lead you guys astray. I don't actually think if I do a slight error in the numbers, it's going to actually cause you guys to be wrong. It's just going to make you guys feel so important to be able to tell me that I did something wrong. That's the problem. It's the social part of it. Now that's it in meters, keep in mind, because the units we put in were meters. The answer we got out was meters then down here, but it said in kilometers. So there's 1,000 kilometers or 1,000 meters in a kilometer. So you divide this by 1,000, you get this instead. Oh dear. But it said what, the 2 decimal places. So then it would just be 2.34, because as I said earlier, if it says 2 decimal places, you want these numbers, and then you look at the next number, and again, because that's higher than 5, you increase it to, instead of 33, it's 34 kilometers. All right, now that is that's an example of sine cos tan. I'll do it kind of backwards now, just to show you the inverse, as I was warning you about. I don't think I've set one up for that, so I'm just going to run through it here. Imagine we had the exact same triangle, and they'd given us the 49, and they'd given us the, I'm just going to call it 2,339 kilometers or meters, right? Just don't worry about it. I'm just putting it into. You're making this as much of a work it backwards to figure out what this angle is. They might do this instead, where they give you the triangle and they give you 2 sides, and if they ask you for the 3rd side, you use Pythagoras, but if they ask you for the angle, you have to use SOHCAHTOA. Again, if they mention an angle, we're going to use SOHCAHTOA. And it's similar to before, because you notice we have the O and we have the A, so we're still using tan, but this time you'll notice in the setup of it, in the setup of it, you still do tan of the angle, but because we don't know the angle, it's going to be tan of 30, or tan of theta is equal to O over A. Again, you sub in the relevant information, and you'll notice then the actual line that you've set up, which again you get most of the marks for, is tan of theta is equal to 49 over 2,339. Now, beforehand, like we said, when you have squared on one side and you want to get rid of it, you do the square root on the other side. If you do multiplication on one side, you do division on the other side. If you do division on one side, you do multiplication on the other side. If you have tan or sine or cos on one side and you want to rip it off of the angle, like leave this guy behind and bring it to the other side, it becomes tan inverse. That's where the inverse comes into it, and it's tan with like a little -1. And on your calculators, you have to press shift before you press the tan button to get that up. And if you do that, should be. I'm hoping it will be. I'm just going to clarify. Yeah, you get, because I rounded the 2,339 slightly. The answer we get is 1.200120821, which you'll notice is extremely, like if I round it, is going to be the 1.2. So that's just doing it backwards, and that's where your inverse comes into it. That's SOHCAHTOA. I'm probably just going to move on from that now. I know I'm kind of running through it, but you can pause it, of course. I'm just worried that it's going to be a long video and you guys aren't going to be happy about it. This is also an ordinary level question, but it's advancing into non-right angle triangles. So the diagram below shows part of a roof part of the roof of the smaller shed, not the scale. Some measurements are marked in the diagram. Yeah. So you'll notice immediately not a right angle, and as I said earlier in the other part, if it's not a right angle, do not assume it's a right angle. If you don't see any evidence of it being a right angle, do not assume it's a right angle. They might do, like if they had this, happy days, or if they had the L, or if they had said it's a right angle, or if they said horizontal and vertical, if they said anything like that, you could then be like, oh, okay. You'll notice there's nothing here indicating a right angle, so we are not going to assume it, for the love of God. They give you 0. So they're saying show that BC in these lines, that means show that the length from B to C, right? That's something that people just don't really, you need to watch out for that. That just means show that the length from B to C, this line, is 4.65. Now, sometimes they'll do that and people will be like, grand, that's the answer, I'm going to use that. They don't really want you to do that. They want you to kind of ignore that for now and then do the maths, and then at the end just kind of go, oh yeah, I was right. The reason they do that here is because even if you fuck this up, they want you to be able to jump down to here and still be able to do this fine. Because, you know, you might, if you knew what that was, this question becomes easier. When they put the question, when they put the answer in the question, they're not really saying use this here. They're saying use it in the future ones. But technically you can, but I wouldn't advise it, because if you fall into the habit of doing that, you kind of forget how to do it if they don't give you the answer, which they might do as well sometimes. But we have to show that this side is 4.65. Again, just draw a shitty little, well, okay, that's too shit, but I'm drawing on my lap, right, so don't be judging me. That's 30, that would be 3, that would be 7, that's A, B, C, and they're asking us for this side. Now, I did mention it, I think, in the earlier part, but I'm going to reinforce it here. Well, first off, in a non-right angle triangle, it's either the sine rule or the cosine rule, but how do you find out which one it is? If you have a matching pair, you use the sine rule. You'll notice we do not have a matching pair, as in we do not have an angle and a side that we know both of. None of these arrows lead from a number we know to a number we know. They either start with a number we know or end with a number we know. I can't, really... that's just the best way of going about it, right? So immediately we know we're using the cosine rule. And they were nice in this question in that the angle we're going to use is a capital A. So the cosine rule we have is going to end in a capital A. So it's going to have a cos A, it's going to have a BC. They were just nice with the letters here. We can fill this in. Now, you don't have to write it backwards like this when I'm doing it, but I'm just doing it just for spacing and stuff. But what I was going to say was, because it ends in a capital A, the other two letters are going to be B and C, and the other end will be an A squared. Yeah, keeping in mind again, sorry, maybe I should have said this earlier, if this is the A, capital A, this is small a, if this is capital B, this is small b, if this is capital C, this is small c, because they're all opposite each other. All the units are the same, they're all meters going into it, and they want the meters that are coming out of it, so that's happy days. And then we just fill in the stuff that we know. We don't know A squared. B squared, it'd be 7 squared, 3 squared minus 2 times 7 times 3, cos 30. Now, yeah, so in the cos rule, they'll either give you one where you don't know this, or you don't know this. Those are the two variations they'll give you. You'll notice this one is this one was obviously missing, and that's by far the easiest one to do. Because you'll notice all of this you can just throw in the calculator all at once and just immediately figure out what A squared is going to be. So hold on now, let me type that in just to make sure. 49 plus, minus 2 times 7 times 3 cos 30. I am in degrees. Good lord. 21.626, no, whatever. Again, A squared is equal to that. So A would be equal to the square root of the 21.626. So then A would be equal to, now on your calculators again, I don't know if you guys notice, if you have the answer to 21.626 or whatever written on the bottom and you just immediately press square root, you can press the answer button on the bottom right and it just remembers what the answer was. And when I do that, I get 4.65047, 6647, but round it to 2 decimal places. would be, I know I'm taking it outside of the box and you guys aren't supposed to do it, but don't judge me. Do what I say, not what I do. And that's 4.65, which is what they said. Cool. So that's the cosine rule, and we use the cosine rule because we didn't have any matching pairs. The other variation of the cosine rule, do I have one set up for that? I don't. But the other variation would be if they don't tell you the angle. Again, I'll just do it in reverse here. No, I can use it for part 2. I think part 2 you could use either of them. And I will do that, I guess. Yeah. I'll do it once with the sine rule and once with the cosine rule. And I'll explain why I know that we're about to do that. Here they say find the angle ACB. The two lines mean, again, the length. This little bit here, the inequality symbol, the thing that you're used to seeing as the inequality to crocodile, means the angle from A to C to B. That means you start at A, draw to B, draw to C. Because those are the three letters they meant. Oh, no, not. Those are three letters they mentioned in order, but it would be from A to C to B, right? And you notice, oh, we traced this angle, so that's the angle they're looking for. Again, don't really make that much of a mess in your original diagram. Fuck up your own diagrams if you want. It's easier for me because I can rub stuff out. And we're going to call this capital C because they gave it a letter. We could call it theta, but because they called it C, I'm calling it C. So this means find the length of ACB, and that means go from A to C to B, and that's the angle they're looking for. Give your answer to the nearest degree. Remember that, yeah, the thing that we found. Now I can put that in, the answer that we got from before. That's not really clutter in the original diagram. If you put in the actual measurements of things, but like labeling things HO and A, or you know, the ABC, even what I did up here, it's fine at the minute, but it can get too far. Now you'll notice again, still not a right angle triangle, so we can only use the sine or the cosine rule. Do we have a matching pair? Now we do have a matching pair, because you notice we have the 30 and we have the 4.65. So immediately we can use the sine rule, and what we're being asked to find is an angle. So what I'm going to do is I'm actually going to write the inverted version of the sine rule, which is fine. I think I hinted at it again earlier, that if the thing you're looking for is an angle, write the sine rule upside down, which is completely legal, completely allowed. It's just a lot easier that whatever one you're looking for, you write the variation of it that has that bit on the top. Again, we were lucky that they used A, B, and C, so it matches perfectly with your log tables, but sometimes it won't, and then you just fill in all the nonsense that you have. Capital B we don't know, so that's just that. Sine we don't know, and we're looking for it, so it's that. Now, a lot of you have kind of mentioned this recently to me. You don't like that there's 3 fractions and 2 equals. We're only going to take 2 fractions and an equals from this. We want the fraction that's fully filled in, and we want the fraction with the thing in it that we're looking for. So because we're looking for the capital C, we're taking that guy. We're not looking for capital B, nor would it help us find other ones, so we do not care. So we're going to just take it over here, the 2 that we know, or care about. I won't say no, in fairness. See what we actually care about. And then it would be like this. You'll notice we want to get the C on its own at the end of the, you know, we want C equals or equals C. I know you guys don't like that, but it, you know, it's the same. So we want to just get sine C on its own first off. So how do we get rid of it dividing by 3? Again, we multiply on both sides by 3. And then just on this side, because you're dividing and multiplying by 3, and that's the opposite of each other, they cancel out. And you're left with 3. Now, people can write this different ways. On the calculator, this will work. If you just write it like, I think you might need that bracket, you might not, but, you know, it's not going to penalize you for putting it in. You get this. And you can put all that in if you want to, just to get an answer, get a number. But again, because you're ripping the sign off, I'm just not doing it out of laziness. It's technically more accurate my way as well, but I'm just, you know, I don't want to write it all and say it all. But if you're ripping the sine, cos, and tan off, it becomes sine inverse again. Now, again, as I said, it's like more accurate, but not enough that it actually matters for what you're doing, particularly in an ordinary level. Maybe in honors, do this if you get me. Like, don't don't break this down first into just like a single number in this position, like 12 point whatever the hell. Kind of try to leave it, but it's not the end of the world if you don't want to. If you want to just figure out what all this is first, sub it into and then put that into the sine inverse bracket instead, that's fine. And then I'm just going to slap all this in here, sine inverse. Yeah, obviously that's a lot of brackets, but I think it's fine. You guys, I think you're okay enough with the calculators, but you know, we'll see. We'll see. I'll live to regret that. And then when you do it all, I get 18.819 blah 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 equals C, and they said correct 2 decimal places. There was more stuff, we don't need it, but the 2 decimal places, it would be 18.82 degrees. Okay, now that's an example of the sine rule and the cosine rule. What I'm going to do now is I'm going to do part 2. Part 2 works out exactly fine as well if you use the cosine rule. It's safer for you guys not to do it, but I'm going to do it just in case, because what they might do is they might give you an example where you have to use the cosine rule. You don't want to be limited to using the cosine rule, and it will be slightly different to the variation I did here, in that it won't be this that's missing, because again, that was easier because we just slapped all that into the calculator in one go. But sometimes it will be this part is missing, and people fuck that up all the time. So I'll even change the color pen. I know. But you'll notice for this triangle, if I did it out here again, because it is starting to get a mess, you know, you can see like kind of what I'm hitting at. I know I'm doing extra stuff here, but you can kind of see that it is just, it keeps like accruing new numbers and new letters and stuff every time, and it just gets a bit much. Now we know C is 18.82, but what I'm going to do is pretend we don't know it, and we're going to go at using the cosine rule. And I know I said that if you have a matching pair, use the sine rule. That's like what you need to stick with. I just happen to notice that this also works with a cosine rule in a way that I wanted to. And this would still be C and capital A, I guess, and A and B and B. We do the cosine rule. Now this time, this is the angle we're looking for. So instead of the capital A at the end, it's going to be a capital C, which means it needs to start with a small c. And then the other 2 letters can be in any order after that, that's okay. But as long as the, oh my god, as long as the first and last letters match. Happy days for everybody involved. And then we fill in all this crap, 3 squared. Something else as well, just watch out, make sure that, like I'll mention this probably other things. Just make sure that's a 2, and I know here obviously you're not going to confuse it for anything else, but in complex numbers, mostly guys, let's be honest, will write 2Z, and then, you know, your Z's and your 2's, your Q's and your 9's, your, what's the other one? 1's and, I don't know, L's, I guess, but there was another one, T's maybe, and something, I don't know, just keep an eye out on it, you know what I mean? Make it obvious that the things aren't going to, like, trip you up when you, because, you know, you might go, oh, I'll remember it, but then you look away at something else, some other, you know, complicated enough part of the maths. And then you come back and you're like, the hell is this? Or not even that. Sometimes I've seen you just like come back and just assume that would be a 22, for example, in what I just did. And then you just kind of run off with it. Now, here, the reason I'm doing this is because every time people do this, they fuck this up. Every time. This guy and this guy, you can put together in a calculator. And that's fine. And just like get one number here as an answer. Like put it all together at once. That's fine. But the -2... the 4.65 and the 7, you cannot do that with this. You can't do all of these together. You have to treat these two. Okay, obviously I made a mess with all these things, but this, there's like a split here because these guys are attached to the cos C. So putting this guy, and this guy together would be like putting a 1 plus a 2 plus a 3x together. You can't do it. You can add these two together, that's fine, but this guy has to just stay as 3x, right? So just keep that in mind. Everybody messes that up. So what we have to do is we have to treat it differently. What you could do is square both of these out first and then just get the answers. I don't want to do that because it's just going to make a lot more right. And so I'm going to kind of skip a step, and you can do it this way as well. But what you could just also figure out what these are first and then bring the numbers over afterwards. But what I'm going to do is do this. Whoopsie daisies. Now it can lead to mistakes actually, because people will probably type this in wrong in the calculator. You don't need brackets here. You can, on the calculator, you can write this perfectly, because we want the answer to be minus whatever the hell this squared is. Because, you know, if you'd done it over here and got the answer, like for example, for the 7 squared here, you would have gotten 49. Bring it over, it'd be minus 49. So we do want it to read that as minus 49. Here is just all this crap again. We get this. That's going to be 9. That's going to be... That's going to be, oh my god, 21, 6225. This is going to be, what's it going to be, 9.3 by 7, 63, 60. I don't know if that's, hold on, I have to do that, I'm not entirely sure. 65.1. Oh, close. Oh, I even understand why it would be 1 as well. That's upsetting. But basically, just be like this. You know, you put all these together. What's that going to be? Minus 61. I have to redeem myself. 61.6. But I really shouldn't. I should make sure I get these things right, because if I fuck these up, you know, it might not be fantastic. This seems like there's something wrong, but we'll see. Again, we want to get the c on its own, so we need to get the cos c on its own, so we need to get rid of this. And how do we get rid of something that's... Now, people would see that with a minus, be like, therefore it's taken away, so I need to plus it to get rid of it. But it's really a minus 65.1 that's multiplying by the cost that we want to leave behind. And it's always what happens between the thing we're moving and the thing we're leaving behind, and that is multiplication in here. So in order to get rid of it, we have to divide by minus 65.1. We're going to do that on both sides. And then whatever the answer is here, I'm not going to do it, I'm just going to leave it as the fraction. The two minuses can cancel. You can put them in if you want, but I'm just going to ignore them. I'm sorry, again, this isn't how I designed the question. I'm doing this backwards, so I'm kind of hoping that's why it looks so weird. Why the numbers are all so strange. I don't think they'd really do this, particularly not an ordinary level for in the actual leave insert. I'm just kind of I'm close enough that I'm okay with it. Because I made a lot of rounding and assumptions to kind of get this to work out, so don't worry about it. I just wanted to show you an example of how to get it. This is missing instead. And you bring the cos over like before, and if you rip it off the angle, it becomes cos inverse, and then it'll be 61.625. You can have a lot of rounding, so when you type this in, actually, it's not perfectly the 18.82. But again, that's okay, because I didn't design this question for this. I'm just kind of shooting it around the place till I can show you an example. And you get this, again, slightly off the 18.2, because if you rounded that to 2 decimal places, it would stay 81. You get me? Because the next number on would be a 1. But then C would be that. Capital C, which is close to what we got. I just made assumptions. But you'll notice that one's a lot harder than if they just... in this example, where just the only thing that's missing is the small a. If the capital A is what's missing, it's a bit of a harder one to do. And that's what we just did there. A lot of it is handy maths, but you move the bits over, but you have to move them move these two over first. We did that. Then you have to get rid of this guy by dividing on both sides by that number. Then you get rid of you move cos becomes cos inverse. You know what I mean? There's like 3 jumps you have to do. Whereas here it was just slap it on the calculator and you're done. So yeah. So that's 2 versions of the cos rule, the 2 ways they can ask it. There's also the sine rule here. I did it for... This one's actually the harder one, in my opinion, where the sine parts are on the top. You might get one where the sines are on the bottom, and I think that one's slightly easier, but we're going to talk about... I think we're going to talk about that one over here, because this one is in the honours paper, but that doesn't mean you ordinary people can jump out just yet, because it could possibly come up in the actual ordinary level. It's still maths that's on the course. It's just a bit... You know, they get a bit weird, and they, as I said, in the past few years, and they're trying to just kind of... They're trying to see who's the best of the best. You know what I mean? Who's the super mathematicians? So they'll even though the maths inherent in it is the same, but like they'll do weird shit like this in the hopes that, you know, people will panic and just not do it. So the triangle ABC shown in the diagram, cool. Yeah, then it says, I'm gonna get rid of that ever so slightly, just, you know. It says then the distance from A to C, because remember that's what those bars mean, is equal to the distance between B and C. So they're saying this guy from A to C is the same as this guy, which is B to C. Which would mean it's an isosceles triangle, if you remember that. It's spelled some unholy way like this, I think, maybe. Two sides are the same, but if two sides are the same, their opposite angles also are the same. So if these two sides are the same, these two angles have to match as well. Keep that in mind. That is some trickery that is involved with it. There's also another part, oh my god, I don't care. There's another part that I want to talk about as well, but I'll get to that in a second. Hopefully I remember that for everybody, so don't jump out just yet. For this triangle though, they said these two are the same. I'm just going to call them X, because I'm crazy, right? Because they're the same, we can call them both X. So that's that gone. The angle ACB is 45, they put that in, so that's gone. A to B, the distance is this as shown, that is there, so that is gone. Find the length from A to C, which is just this guy, so they're basically asking me to find X, because I used X, because I'm unique. A couple of ways of doing this. What was I going to say about the SS? Oh yeah, before we actually do this question, I'm going to just take a moment to I'm going to use this as an excuse. In the earlier question, or in the earlier part of the video, I think I said that if you can find an angle before you even start, before you get into the maths, go for it. We know that these two angles have to match. We know that the three angles in a triangle have to add up to 180. So what we can do is we can just say, well, 180 take away 45 is 135. So that means that these two angles have to match but add up to 135. So what you do is you do 135 divided by 2. What is that going to be? 67 and a half, I think. So we immediately know both of these angles. Yeah, it's outside of the thing. 67 and a half each. The way I'm going to do the question would not have been doable without those angles. There is another way of doing it, I'll show that in a second, but that's kind of more complicated, and also I'm just using this as a way of getting out a certain way of doing the sine rule, I think. But yeah, if you can just do triangles or get angles like that, that's fine. There are also ones I've seen where they might have like a straight line like this, and then they'll have an amazing triangle like that, and they say, oh, this is 42 degrees and this is I don't know, 50 degrees, and you'd say together that makes 92, and you notice here this should be half a circle, which should be 180 degrees. So if these two are 92, this would have to be 88. So even though they didn't give us that angle, if they gave us this guy and they gave us this guy, we'd be able to find it. So just know in the same way that a triangle, the three angles in a triangle have to add up to 180, the three, or however many angles in a semicircle have to add up to 180. So if one of them is missing, you can just add all the other parts together and figure out what's missing. Like I did, or well, no, not really. If there was another one here, let's say that was 60, then you could say, well, those two together add up to 148, so therefore this would have to be 32, because all three have to add up to 180, so you just do 180 minus these two. I think you're all okay with that kind of stuff, but you can just you notice you can just do all that shit without even doing, like, I haven't even mentioned which rule we're using. That's cool as well. Another thing that I might not get around to, equilateral triangles are ones where everything is the same, all three sides are the same length. So it'll be like x, x, and x, and all the angles are the same. So it would be theta, theta, and theta, but because it always has to, the three angles have to add up to 180, and we know that the three of them are the same, it works out that in an equilateral triangle, all three angles have to be 60. Sides could all be different. You could have an equilateral triangle with sides of 5 or sides of like 3,000, but the three sides would be the same no matter what. Anyway, with this question, not a right angle triangle. Do we have a matching pair? Yes, sir. Sine rule. And what we're missing is a side. So I'm going to use the sine rule variation with the sides on the top. Like so. Now, this is an honors one, and you'll notice that, like, other than this, it looks fairly, and this, it looks fairly okay. I'm just curious where it's gonna get you. Let's see. But yeah, this is what you do. You set it up like this, because again, what we're looking for is a side. So I want the version with all the sides on the top. We fill it in. We know that's capital A, so this is small a. That's capital B, so this is small b. That's capital C, so we know this is small c. So we get x over sine 67.5 is equal to, again, x over sine 67.5, which is equal to, now the 10 massive square root of 2 minus small square root of 2 over sine of 45. And again, with the sine rule, you want to pick whichever one is. You want to pick one that's filled in and one that has the bit we're looking for. You notice this one's fully filled in even though it looks horrendous. And both of these are actually the same, so we're just going to take one of them. It doesn't really matter, because regardless of which one we pick, we're going to find out what x is. And that's what they asked for, and so, you know, we just pick these two. I'm just going to, like, you know, take over from this one, just hijack this, if that's okay with you guys. So, yeah, it's the same kind of scenario. Actually, I'm just going to rub this out. Same kind of scenario, because you'll notice that we want to get x on its own, but we don't have x on its own because it's being divided by a sine of 67.5. What's the opposite of dividing by sine 67.5? Multiplying by sine of 67.5. So I'm going to multiply on both sides by sine of 67.5. And then they cancel out here, and you're just left with the x. I might just rub that out rather than write it out again. Again, you guys can rewind it, obviously, if you feel like you've missed what I've done there, but that's okay. So, I think I'm in the clear for that. And then you just type this into your calculator. Now, you want to put the brackets around the massive fraction like I just did there. The calculators are, you know, they're coded in a certain way that the person who wrote it makes sense. It makes sense to, well, the majority of it makes sense to me. But you guys, I'll disagree with it, but I hate to tell you this, no one really cares. 7.5, did I do this right? Okay, okay. Well, like, when I type all that in, I'm just getting x is 10. That's not what I should write it as. I get x equals 10. I wasn't really expecting it to be that simple. It could be that it's such a weird number that the calculator just went, fuck it, it's 10, just trust me. And there's mad decimals, but they didn't say round it, they didn't say leave it in third form, so I guess 10 is just the answer, which is a lot nicer than I was expecting. Anything else I want to do? Yeah, there's the area formula one that I didn't really go through. I think that's kind of it's handier. If it says find the area, there's just, like, you know, that formula, and you just fill it in. And the whole thing about the area is... Oh, yeah, I'll talk about... Okay, hold on, I forgot something. I'll ignore the area for now. Another way to do this question would have been... And I'm going to rub all this off just for a second. But again, you'll always have it just using the rewind, so it's fine. What you could have done if you want to be a special little student, right? You could have just split it down the middle here. I know that's not perfectly in the middle. I know. The thickness of the pen is working against. You see, I'm not okay with that. But if you split it up the middle like this, if you split an isosceles triangle in the middle, look, just live with it, Jesus. You get two right angle triangles that are identical, right? So I'm just drawing it again. That's annoying the balls off me. If you do it, you get like this. There you go. Get a perfect right angle triangle like so. Now, what we know is we do still know technically this is 7.5, but let's say you don't. We know the 45 degrees has been split in two, so this is 22.5. And we know down here, because it's half of this length, it's going to be half of this. So it's going to be like this atrocity here, all over 2. And if you put that in your calculator, it just turns into 5 root 2 minus root 2. So that goes away. And then you can just do SOHCAHTOA stuff again, because you'll notice you have one side You have the base being this length, and you have an angle here. So if you were to label it, this would be h because it's across from the right angle. This is the opposite. This is the adjacent. So you have the opposite, and they've asked for the hypotenuse. So you'd use sine, because according to SOHCAHTOA, you know, that's what links the opposite and the hypotenuse. Say sine is equal to over h, which is equal to, you know, this awfulness over h. Multiply both sides by h to get rid of it. I'm just going to ignore that. Multiply both sides by h here and here. That goes away. But then if you want to get the h on its own, you would then have, because, you know, in the next line you'd have this. If you want to get h on its own, you'd have to divide by the sine of 22.5, because you're multiplying the h by the sine of 22.5, right? So you'd get this guy. Okay, hold on. I'm starting to lose it a bit because I have, like, I don't want to wrap it up. I don't want this to go on for much too longer. Of course, you guys will know roughly how much longer it is left anyway, because it'll be done. But if you do that, boom, boom, and you're just left with h equals that thing. And if you type that in the calculator, hopefully you get the same thing. You get 10 again. We'll see. Moment of truth. 4 root or 5 root 2 minus root 2. And then put that all over sine of 22.5. I forgot to put in the bracket, so it hit me with an error. It does, yeah, 10. Okay, thank the Lord. Yeah, that's, yeah. Yep, that's another way of doing it. Area, though. The area formula is A equals AB, half AB sine C. That's the general trigonometry formula. There's like 4 different area of a triangle formulas that we have to talk about, but that's that one. And it follows the same pattern as the other ones, that whatever angle you have, so let's say now with our newfound expertise, we know that that's 10 and that's 10, which we do. If we wanted to find the area of this triangle, we only have one angle. So what we do is we'd use this guy as our, now luckily the capital C is at the end in the log tables, and the capital C is the angle we have. If it's not the capital C, let's say we had the capital B instead, you just rearrange this where the capital B is at the end, and then the other 2 letters are in here, you know, that would be fine too. And it just so happens for our one that it works out exactly the same as in the log tables. And when you fill this in, you get a half 10 by 10 by sine of 45. What's that going to be, like 50 over root 2, or you guys in your calculator might tell you it's 25 root 2. I don't know, something weird. But that's just how you use the area formula. You can just throw it in the calculator. I don't want to admit defeat, I suppose. But that's what it is. Is that okay? You can't answer that question. Let's just have it. That's the area. If you're in a right angle triangle, you can always still use the half base by perpendicular height. That's kind of like seen as more basic and more so used in geometry, but it can sometimes come up in this. So it'd just be a half BH. Technically we're doing sine of 90, but the sine of 90 is 1, so it's technically still the same formula. There's also, technically it can also work if you have a triangle like this. That's not going to link up apparently, but alright. But then in that example it would be, this would be your height and this would be your base. Because it's always the vertical height that's perpendicular to the base. You know, this one happens to already be perpendicular, but you know, this one is also perpendicular. There's also that other one in coordinate geometry that you wouldn't use here, but just to reference it. It's like this nonsense. It's on page whatever 18 of your log tables. I can't remember. I'm probably fucking up the while we're in the x1 y1 go. That's not important for here. But yeah, that is, as far as I'm aware, everything I wanted to say on the trigonometry. That is just the sine rule, cosine rule, SOHCAHTOA, Pythagoras, area formula, all the things on page 16 of the log tables. I think this covers all of the ordinary level Again, I might make this 2 separate videos where I don't really know what I'm going to do with that. For now, I'm just going to do it all out. I'll sort that out later. But yeah, basically, the ordinary levels don't need the other videos, as far as I'm aware. Right? If that changes, I'll point it out. But like, look, what are you going to do? I suppose. All right, peace. Of course, I finished the thing, and then I started to do something else, and all I could think of was like the edge cases that I kind of forgot to mention. Yeah, so normally, what one of them would be is in both of the exams, in honours and ordinary, they will have a situation sometimes where they'll put 2 triangles together. Hold on. Here we go. They'll have where 2 triangles are together, so you might have like this shape here, and then what they'll do is they'll also have like this type of nonsense. You know what I'm trying to get at, right? If the 2 things were matching perfectly. I can probably just remove it actually. But if the 2 things are matching perfectly like that, in the ordinary what will happen is they'll give you the 2 triangles and they'll probably ask about the 2 of them separately. And what you do is, let's say they say find D, and D is here. That means you're going to use this triangle, and then, you know, if it said find F and F is here, it means you're going to use this triangle. In both scenarios, don't forget that this side here is in both triangles. So if they tell us this is 10, even if you draw out the 2 triangles separately, it's going to be 10 here. Or if you do that one, it's going to be 10 there. You know what I'm getting at? Again, sorry, that's habit. Just ask a question. Obviously, you can't answer me. So that's what to watch out for, particularly in ordinary level. It's just whatever one you find. In honours, what they'll do is they'll put D here, but they won't give you enough information here to just use that triangle. So what they'll do is they'll give you like information here and maybe here, for example. And what you'll do is you'll do like, that looks like the cosine rule, right? Because you don't have a matching pair, it's not necessarily a right angle triangle. You'd figure out what number goes here, and then you'd use that and that and that, let's say, to figure out what D is. You use the cosine rule again. You know what I mean? Don't get too bogged down with it. Sometimes you might have to do an indirect thing, even though they didn't specifically ask you to use the cosine rule here to get this guy. You might have to do it just to get enough information to find D. Another example I thought of while I was away there was, you know, I won't be away for you, but it was for me. I did one of these earlier where they might write stuff like this, and obviously that means those 2 angles are 30 and 45 respectively, and use that information to figure out this would be 105 maybe, doing the 180 minus. There was an example though in the honours leaving cert once where they did this, and this was too small for them to type in 5 degrees. So what they did was they didn't even use the arrow. It was kind of a bit weird how they did it. They did this. That means the 5 should be in there, right? Just to watch out for that. There was another one someone showed me where it was like 0.88 and they did radians and they did that. And that's another thing too, actually. There was a question once where they had the 0.88 radians and they asked you for whatever this length was, I think, and they didn't give you either of the 2 angles, but I think they gave you this side here. Yeah, they gave you the other 2 sides, I think. Yeah, and as far as I'm aware, unless there's some shenanigans I'm ignoring there, what you have to do is you have a matching pair that should have these 2, and you would use the sine rule, but there's no way of using the sine rule to directly get D. So you'd use the sine rule, and it would help you find this angle here, right? Just trust me on that. And then once you figure out that guy, again, maybe I'm missing something, but once you figure out that guy, you add this and this together, take it away from here to figure out what that angle is, and then do the sine rule one last time, because then you'll be able to figure out what D is. I'll also point out for honours in particular, if it's 180 degrees as in a triangle, it's pi radians, don't forget. So if they, instead of doing it as degrees, like here they said this was 0.08 or 0.88 rad, as in radians, instead of them having to add up to 180, the 3 angles have to add up to pi. Alright, just keep that in mind. I think that's everything. I hate this part.